I did ask you to do the math on question number 8. So let's talk about how you guys did with that. So the question was, what's the distance between the two airports when the planes stopped? So what was that distance? Remember, this is the math that I asked you to do by class time today. So if you're scrambling to do it right now, it's too late. Nobody? Can you just say it louder? Yeah, okay, so let's talk about, why are you changing your mind there? Okay, yeah, because the directions say they're to round to the nearest mile. So yeah, it would be 1124 miles. So if you didn't try that, shame on you, you need to go try that on your own. Now that you know the answer, you can get that answer on your own. So then let's go into, just scooch that over a little bit. Let's go into the last question. And really, the math isn't what the challenge is here, it's getting the picture that's the challenge, okay? So for this one, let's read through it. Let's get an idea of what's going on, and then we're gonna go back and read through it carefully. So the first time is just to skim through it to see what's going on. You've got a ship sailing due east at the rate of 16 miles an hour. It records the bearing of a radio beacon northeast. Records the bearing of, that just means the captain sees something. Okay, that's the English version. 2 hours later, he sees the same beacon. Now it's northwest. How far is the ship from the beacon the first time? How far is the ship from the beacon the second time? So that's just kind of a, what I like to call the scream and run mode, only you don't have a chance to scream and run. So now let's go back and let's decide what exactly we should draw. So looking at the very first few words, a ship sailing due east. What does that look like? It's horizontal, okay? So let's draw horizontal then. So my ship is sailing due east. It might look something kind of like this. Now, it makes life easier as we're working in a big group if we label things. If you're working on your own, it's not as big of a deal, although it gets really difficult when you start doing your math. But so let's go ahead and label. Since the ship is sailing due east, let's say that the first time the captain saw the beacon, let's call that when he was at point A. And then he traveled for a couple of hours. And so then let's say the second time that he saw the beacon, we'll call that point B. Same ship, same captain, same radio beacon, okay? It just depends on where the captain is. Okay, so now let's make a little bit more sense. Let's go a little further. We only took care of like the first 4 words. So let's go a little bit further. You've got your ship sailing due east at a rate of 16 miles an hour. Okay, that's important. Go a little further. How long did he travel? 2 hours. So if he was traveling 16 miles an hour for 2 hours, how far did he go? Okay, so we'll just put a 32 miles down here. Now, the first time he saw the radio beacon, remember he was at point A, okay? What direction, as he's in the ship, what direction was the radio beacon? Northeast, northeast. So let's remember how we draw that. Remember, the first thing that you do is you draw the whole north concept, right? And I did this just with a dotted line just so that we can figure out where north is. Where is east of that? Yeah, it's to the right. So my east is going to be in this direction. So what I'm going to do then is this is the actual line of sight that the captain had. And what is that northeast angle? Okay. There is a typo in this question. This right here, this angle should be, ooh, I think it's 4310. I'll tell you when we get there. I think I'm right. Sorry about that. Otherwise, we cannot, with the amount of knowledge that we have, we can't, if I keep the other number, we can't do this question. Now, come chapter 11, we could totally do this question, but not with chapter 9 knowledge. Okay, then, thank you. All right, so all right, so I got myself distracted. Mistakes will do that, right? Okay, so the ship is taking his trip 2 hours down the road. Now he's at point B. So what direction do I find that beacon when I'm traveling and I hit point B? Yeah, now it's northwest. So it's the same thing. Let's establish the north line. So there's my north line. Where's west of that? Yeah, it's to the left. And we're told that, well, let me go ahead and draw that northwest line. And the angle for that northwest line, I think, is 4310. What do you think is at the intersection of the red and the purple line there? It's the radio beacon. Yeah, let's call it C. Okay, so now it says, how far is the ship from the beacon the first time? Now, what's a name for that distance? How far is the ship from the beacon the first time? What's a name for that distance? Side B. Why is it side B? It's opposite angle B. And then the second question, how far is the ship from the beacon the second time? What's a good name for that one? Side A. All right. Now, as you look at this triangle, what's the problem? What's the crisis here? I don't have any angles inside the triangle, right? I have nothing on the inside of the triangle. I have several angles outside the triangle, but I don't have anything on the inside. What am I going to do to get angles on the inside of the triangle? Yeah, complementary angles. So let's go with angle A first. Remember that dashed line was my north line, and the horizontal line was my east line. And what do you know about an east line and a north line? They have to meet at a right angle. They have to meet at a right angle. All right, so let's find the missing angle. So you're going to want to do 90 minus 46 degrees, 50 minutes. What do you get? Okay, phew. So we got 43 degrees, 10 minutes. That's what you found? Okay. So now I have an angle inside my triangle at point A. Okay, can you just use a little bit of knowledge now to figure out what the angle on the inside of point B is? Isn't it 46? And then what about the angle on the inside at point C? Has to be a right angle, because the angles on the inside at A and B are complements. So when two angles are 90, that leaves me with 90 degrees. All right. So then what will I do? What kind of math can I do to find side B, which was my first question? Say it again. Okay, so if you're going to use tangent, how would you set that up? Which angle do you want to focus on? Okay, angle B, so you're going to be focusing here. And so the tangent of that angle would be what? Be careful. Be careful. Tangent, SOHCAHTOA says tangent is what now? What does SOHCAHTOA say tangent is? Opposite over adjacent. And gotta be careful because the picture is turned a different way. If you're focused on angle B, which side is opposite? Which side is opposite the highlighted angle? Angle B. Which one? Side B. Which side is adjacent? A. What is the 32? It's the hypotenuse. It's opposite the right angle. And you can't ever use the hypotenuse for an opposite or an adjacent. The hypotenuse is simply the hypotenuse. Does that make sense? Okay. All right, so let's try it again. Is tangent, are you sure tangent's the one you want to use? No, because if I try to use tangent, I'm going to get two unknowns. Okay. So, new idea. Sine. Okay, so you want to stick with angle B still? All right, so if we're going to do the sine of angle B, which is my 4650, that will equal what? B over 32. Okay. Now, I'm not going to take the time to go through this, okay? Because you guys know how to solve that. But talk to me about how to get A. Side A. No, you're right. You're right. So you're changing your angle, right? You're focusing now on angle A instead of angle B. Yeah. So if you focus on angle A, you would have sine of 4310 is equal to A over 32. What's another option? Good, yeah, the cosine of this angle being adjacent over hypotenuse. Either of those is an option. All right, so I'll just write down the first one here, 4310 is equal to side A over 32. Okay, and again, the lesson today is not about how to solve that equation. We've already done that. It's more of how to set it up. That's the difficult part. And so let me just give you the answer so that you can try this on your own. So part B here, well, not part B, but side B is going to be 23.3397, and it's in miles. And it doesn't say anything about rounding, so we'll keep it like that. And side A is 21.8919 miles. Okay, so write those answers down, and then that way you can try it on your own and make sure that you're getting the right, that you're doing your math right in the calculator. Okay? Any questions on that? So again, the challenge, in my opinion, is just simply getting the right picture. That's the challenge. The math isn't the challenge. Okay, so you had videos to go through. And this is also the section where you begin working homework on paper, okay? You do have digital homework. You still have digital homework in my lab, okay? That's not different, but I feel like I picked mostly easy questions, easier, not easy, but easier questions. But you need to do the paper homework. It's not graded or anything, but for your practice, for your benefit, to start you practicing for the test. You need to work some paper homework on the graphing. Any questions on the sine parents or the cosine parents from the videos? Any questions on those two parents? Do you guys remember in Math 110 how you started the semester? It was in chapter 2. You started the semester working with 6 parents. You had the identity function, you had the squaring, the cubing, the square root, the cubed root, the absolute value function. Do you remember all those? And you messed with those parents all semester long. And through the semester, you even picked up a couple new parents. Like you picked up the reciprocal function and the reciprocal square function. And then there was the exponential function and the logarithm function. So you picked up parents all semester long. And you always mess with, I mean, that's what kids do. They mess with parents, so I'm told. So we always mess with the parents. Like we shifted them to the right, shifted them to the left. We shifted them up and down, and we stretched them vertically, and we compressed them horizontally. There was all kinds of things that we did to those. This is basically an extension of that topic, okay? 2 new parents, and we've got the sine parent, which is a wave, what's called the sine wave, and the cosine wave, and we're going to learn how to mess with our parents. We're going to learn how to shift right and left, shift up and down. We're going to learn how to stretch it vertically, or maybe stretch it horizontally. We're going to learn how long does it take before this dude starts repeating itself. There's all kinds of things we're going to do, but it's an extension of the topic that you had in Math 110. Okay, the good news is now that you've plotted points for these two, you'll never have to do that again. All those points we had to plot in the videos, you don't have to do that again. Okay, that's the only time. Just to establish what it looks like the very first time, no more plotting points. That's boring. All right, so the one thing that I would like to point out here is the 2 graphs here of the basic parents. From now on, instead of plotting, 300 million points like I made you do on the videos, from now on, you've got 5 values to work with. And those 5 values that you're going to work with is the beginning, the ending, the middle, and then the middles of the middles, we'll call them the quarter points. Okay, so the beginning, the middle, the ending, and then the 2 quarters. Those are the only 5 values that I'm going to make you worry about from here on out. No more plotting points. The basic shapes, you need to know those basic shapes. So where does the sine parents begin? At 0, 0, at the origin. Now, technically, it never has a beginning because it goes on and on forever and ever. Okay, but for our purposes, when we draw the sine parent, we're going to say begins at the origin. Where does the cosine parent begin? At the coordinate 0, 1, right? Up at the top, at a maximum. And so these are things that we want to pay attention to. Tell me this. Look at the beginning of the sine parent and the ending of the sine parent. What's true about their y values? They're exactly the same. They begin and end at the same place, so that the next part of the wave can just continue on repeating, right? How about the cosine parent? Look at the beginning and the ending of the cosine parent. What do you see there? Don't they both have the exact same y value? It starts at a maximum and it ends at a maximum, okay? And so that's how it's going to be with sines and cosines. All right, so let's talk about the amplitude. How high, how low does this graph go? Okay, I gave you a formula for this. And you might want to just have this blue highlighted guy handy, because we're going to use this over and over and over again. And I think I even mentioned in the video that where it says sine, it could say sine or cosine. Okay, this is the same parent function for both. All right, the same standard parent equation for both. I will say this: whenever I see my equation written like this, it kind of bugs me. So that C that you see out in the front, I typically throw it out back. Whether it says a C plus or whether out back it says a plus C, that doesn't matter. Oddly enough, when I leave it out in front, students tend to make careless mistakes. Okay, so it's easier if I just throw that plus C out in the back. Okay, so just keep that in mind. If I don't write it, for sure, I'll talk about it. Okay, so let's just jump right on into our first example. In example number 1, what is my amplitude? It's 3, okay? And we know amplitude is how high, how low. So this means, by the way, what's the amplitude of the parent's sine graph? It's 1. How far up and how far down does the parent sine graph go? Up to 1 and down to -1, right? Because its amplitude is 1. So how far up and how far down is this sine graph going to go? Up to 3 and down to -3. All right, so let's just go ahead and let's mark 3 on the axes. All right, next. What's the ending of one wave of the parent sine graph? What's the ending of one wave of the parent sine graph? It's right there in your notes. Okay, you don't have to look too hard. What is it? No, pi 0? What's that? It is at 2 pi 0. Where are you looking, Juan? The first graph? Oh, gotcha. Okay, but do you see how that's not the ending of the wave? There's still more that's unknown territory there. Yeah, so all right, so what we're going to do, let's graph the ending. The ending is at 2 pi. All right, now, I'm going to ask a series of questions that I'm going to ask you over and over and over and over and over again. I want you to get used to this series of questions so that you learn how to ask yourself the same questions, okay? So what were the 5 magic points again? The beginning and the ending, right? Hey, look, those are on my graph. I've got the beginning, it's at the origin, and I've got the ending. And what were the other 3? The middle and the 2 quarters. Okay, so I still have to get those. This is the series of questions that I'm going to keep asking you over and over again. Once you found the end, first it's not really questions, it's statements. First, you want to take half, and count. Okay, so take half, and count. So when you get to the ending and it's at 2 pi, what's half of 2 pi? Pi. Now, once you're there, take half again. So what's half a pi? Pi over 2. And now all you have to do is count. Because what we're going to do is this is going back to the unit circle concept. Here's 1 pi over 2. If you're counting, what comes after 1 pi over 2? 2 pi over 2. And what comes after 2 pi over 2? 3 pi over 2. And what comes after 3 pi over 2? 4 pi over 2. Does this make sense here? Is this 4 pi over 2? Yeah. And so the first few times we're going to do this, you're going to get to the point where you're like, Ms. Roberts, why do you keep doing that? It's the same thing every time. Stop it. Okay, but it's going to be different. So if I can get you solidified and thinking about that the same time when every time when it's the same, hopefully you can make the connection when it's different. All right, remind me one more time, where does the sine parent begin? At the origin, at 0, 0. And it has to end at the same place. It has to end at the same y value. So I know that my 2 pi has to be at the same y value on the x-axis. What about the middle? Where does the sine graph land in the middle? I know it's pi because I know pi is the middle. That's, sorry, not what I'm asking. I'm asking where does it land when I get as far as pi? Yeah, it's on the x-axis, right? How about the sine parent first quarter? Sine parent first quarter. Where is the sine parent on the first quarter? It's at a maximum, right? So yeah, it's at 1, but if I say it's a maximum, what's going to be the maximum on this graph? It's going to be at 3 on this graph. And what about the other quarter? It's going to be a minimum. A minimum. Okay, so I've got my 5 values drawn. Connect the dots. By the way, these are not mountains. Okay, these are not straight segments. These are nice, pretty curves. It's a nice wave. Does that really look different than the parent does? Well, it doesn't, but if you think about actually what the parent is, remember that the parent only goes to 1. So when I draw it like this, does it look different than the parent? It does. It has a vertical stretch of 3. Okay, now let's move on to the next one. What's my amplitude? No. Say it again. Why just 3/4? Yeah, the formula says it's the absolute value of A. Oh, wait a second. So then does that negative? Do I just get to ignore it? It's totally like not important to me? No. What does a negative out front make you do? Think about Math 110. Yeah, we've reflected over the x-axis. So I'm going to put there that I have an amplitude of 3/4, but I also have a reflect over the x-axis. So there's 2 things going on here. Okay, so let's go through our 5 magics first. Our five values. Where does the parent cosine graph end? At 2 pi, and this guy, I'm not messing with the ending yet, okay? I'm only stretching vertically or shrinking vertically, so I'm not messing with how far it goes before it starts repeating. So the ending is going to be at 2 pi. Take half, you get? Take half. And then count. So you've got 1 pi over 2, what's next? 2 pi over 2, and then 3 pi over 2, and then 4 pi over 2. And again, I know I'm being redundant here, okay, but those numbers will change. Where does the cosine parent begin? Let's be generic. Don't say 1, be generic. It's at a maximum. It's at a maximum. Where is this guy going to begin? Be general. Where is it going to begin? At a minimum. Why at a minimum? Because I'm reflecting it. All right, so let's pick a spot and let's call it 3/4. And so I'm starting down at the minimum. Hey, where am I ending? At a minimum. Remember, you have to begin and end at the same place. Okay, what about the middle? Where is the cosine parent in the middle? Where is the cosine parent in the middle, generically? Where? At a minimum. Where is this guy gonna be in the middle? At a maximum. Where is the cosine parent at the quarters? On the x-axis. Where are the quarters going to be on this guy? on the x-axis. Okay, so I've got my 5 magic values. Let's draw them. Any questions? All right, period. So we've got a formula here. Okay, and this is going to be a lot like the horizontal stretching and shrinking. Horizontal stretch and shrink. Okay, so let's look at our example. So what's one thing that we know when I look at my example? Amplitude is 3. Okay. Now for the period, don't just tell me what the period is, tell me how to find the period. How do you find the period? 2 pi over b. In our equation, what's my b value? What is it? Yeah, it's 2. So if you go back and look at your equation, go back and look at where b is. B is the guy that's in front of the x. Okay, B is the guy that's in front of the x. All right, so we've got here then my formula, 2 pi over b, which is 2. So this is going to be pi. All right, period is, what's period again? That's how far it's going to go before it starts repeating itself. Okay, so this is where I'm stretching and shrink it side to side. Okay, what was the ending for the parent graph? What was the ending for the parent graph? 2 pi. This guy's ending is not 2 pi because, well, let's go back. That's a true statement. This guy's ending is not 2 pi. What was the period in the original parent equation? Let's go all the way back. If I made you find the period, what's the formula again? 2 pi over b. What is my b value in this equation? So what's the period in this guy? 2 pi. That's why it ends at 2 pi. But my new equation, that's not the case. My new equation has a period of pi. This is my new ending. This is my new ending. Now, what is that? What are those 3 steps that I keep saying over and over again? Take half, count. Okay, so there you are at pi. That's the ending. Take half. What do you get? Pi over 2. Take half. Pi over 4. Now let's count. So this guy, if I'm counting, is 1/4. This guy, if I'm counting, is 2/4. This guy, 3/4. If I kept counting, what would this be? 4/4. And it's a good way to check my work. Does that match up? Yeah, so that missing guy then is 3/4. 3 pi over 4. Let's mark our amplitude. Where does the sine graph begin? On the origin. And where does the sine graph end? No, not at the origin. The x-axis. Yeah, it's an x-intercept. It's an x-intercept. What about the sine middle? X-intercept. What about the first quarter? Maximum. What about the next quarter? Minimum. And you might say, but Ms. Roberts, that still doesn't look any different from what the original parent looked like. So let me kind of show you here what the parent looks like. How far up and down does the parent go? Up and down to 1, okay? And what's the period of the parent? Yeah, so that's going to be like out here somewhere. That says 2 pi, sorry, it's dashed, okay? So that would mean my parent graph would look something like, it's kind of wiggly there, but you get the idea. So does it look different than the parent? Yeah, absolutely it does. Absolutely it does. So this was a horizontal compress. We squished our guy in side to side, but there was also a vertical stretch. We made him taller. Okay. All right. Moving on. Number 4. Okay. So now let's talk about shifting. Okay. So this is a horizontal shift, a right and left shift. Do you guys remember what was weird about this in Math 110? Yeah, it always went opposite from what you expected it to do, okay? So let's just jump right on in. So what's my amplitude? 3. I'm not entirely certain why it seems like I got stuck on a 3. What is the period? Yeah, why is it 2 pi? B is 1. So it's 2 pi over 1, okay? And the phase shift, I'm going to call that PS, phase shift. Now, when it comes to phase shift, you are required to give both a direction and a distance. Both a direction and a distance. And by the way, pluses and minuses don't count for direction. Pluses and minuses don't count for direction because pluses can tell me to go multiple directions. Okay, so what's my phase shift? What direction am I going? To the right. Why is it to the right? Yeah, it's opposite of what you think it's going to be. Since it says minus, it's going to be to the right. How far? 3 pi over 2. Now on this one, I should rewrite my notes. I haven't, but can we think ahead for a minute? Think ahead. Don't write anything down. I want you to just listen to what I have to say. Forget the shift for a minute. Forget the shift for a minute and only focus right now on the amplitude in the period. If I'm only looking at the amplitude in the period, how far out am I going to go? I'm going to go out to 2 pi. Okay. Now think about the shift. If I'm going to go out to 2 pi, so my ending is at 2 pi, and then I'm going to shift everything to the right, what's going to happen here as far as paper is concerned? The paper you're looking at, what's going to happen? Say it again. The graph is going to go off the paper. You're going to run out of room, right? So we have to make allowances for that. Yes, I should have rewritten my notes and I should have taken that graph and shifted it over to the left-hand side of the page. But instead of making you redraw a graph, let's just accommodate what we have. Okay, we can be flexible. So let's do this. Instead of making that guy my endpoint, the guy that's circled, let's make the second tick mark my ending. Let's make the second tick mark my ending. Okay, so then if this guy is my ending, and again, forget about the shift for the time being. If this guy is my ending, what value is it going to have? 2 pi. Okay, and let's do what we keep doing. Take half, you get pi. Take half again. Now you need a new tick mark there because you don't have one drawn. So take half again. What do you get? Pi over 2, and let's count. So you've got 1 pi over 2, and then 2 pi over 2, and then get a tick mark. 3 pi over 2, 4 pi over 2, and that checks out. Because now this is going to allow me the opportunity to shift things to the right and not run out of space, okay? So occasionally you're going to have to be a little bit flexible as far as that's concerned. Okay, so let's get our amplitude on there. Okay, here's the steps. First, draw the original 5 magics without the shift. Draw the original 5 magics without the shift. Some people like to do colors on this. You can if you want, but you don't have to, okay? So let's draw the 5 magics. Don't draw the graph, just the 5 magics, okay? Where do my 5 magics begin for this guy? At the origin. From there it goes to the max, and then from there it goes x-axis, and from there min, and then last back to the x-axis. So I just drew some x's where my 5 magic values would have occurred if I didn't have a shift. Okay, you ready? So then the next thing, let's take the 5 magics and let's shift on the distance that they're supposed to get. How far is that? Well, look at your graph. This one was a pretty easy one. How far are we supposed to be shifting it? 3 pi over 2. Look at your graph. Do you have 3 pi over 2 on there? How many blocks do you have to go through to get to 3 pi over 2? 6 blocks. So let's just take all 5 of our magics and move them to the right 6 blocks. That's all we got to do. Okay, so when you take the origin and you move it to the right 6 blocks, where do you land? 3 pi over 2. And now I'm going to draw dots so that I can tell the difference between what the old magics were and what the new magics are. Okay, now take your maximum. Shift your maximum to the right 6 blocks. And put a coordinate. What came after the maximum? X-intercept. So take that x-intercept that was at pi, shift it to the right 6 blocks. What came after the x-intercept? Minimum, shift it 6 blocks to the right. And then lastly, what happened after the minimum? X-axis, so shift it forward 6 blocks. Now you can go ahead and draw. Now I'd love to tell you you're finished and that we can move on, but there's something missing on this picture. What's missing? Yeah, I need those 5 magics, okay? I have the original 5 magics, but I don't have the new magics, okay? So I've got 2 of them, but I don't have the last 3. Now the nice thing is remember we were just counting to get those? Okay, so let's go back. We had 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. What comes next? 5 pi over 2. And then after 5 pi over 2, you're going to have 6 pi over 2, but what will you reduce that to? 3 pi. And then after 6 pi over 2, 7 pi over 2. So let's put those in there. We've got our 5 pi over 2, 6 pi over 2, which is 3 pi, and then 7 pi over 2. So remember I told you there's no more plotting points. You don't have to worry about 300,000 coordinates anymore, but you do have to have the 5 magics. And not the original 5 magics. You've got to have the 5 final magics. Okay? All right, let's look at example 5. I chose a pretty ugly one for this one on purpose. To show you what to do if you've got something that's not gorgeous, okay? What's my amplitude? Well, my amplitude is 1. Okay, how will I find the period? 2 pi over b. In this case, that's going to be 2 pi over 3, okay? Oh, there's a problem. This doesn't look like my standard equation. Go back to your standard equation. How does this look different from the standard equation? Say that louder. Was that you, Michelle? Okay. It's not minus b, is that what you're saying? D, I'm not so much worried about that. I'm spilling water all over myself. Not so much worried about that. It's the distribution. It's the distribution issue. Do you see how on the standard equation, that b value is factored out? Here, my b value is not factored out. Now, that won't affect the period when you go to find it, but I want you to just think in your mind, if you hadn't considered this, what would you have said was your phase shift? 3 pi over 5 to the left, right? Okay, so keep that in mind, all right? Let's write it in the standard form. Let's write it in the standard form. And so I cannot have that b value along with the x. I just, otherwise my formulas won't work well. So you remember factoring is just division. So you take your 3x, you divide a 3, that's why we're left with an x. We all know that, okay? Take 3 pi over 5, divide out a 3, what's left? Pi over 5. Okay. And for those of you who are going, okay, I don't remember. Here's basically the mental that just went on. If you have 3 pi over 5 and you divide by 3 or 3 over 1, how do you divide fractions? Multiply by the reciprocal. So this is 3 pi over 5 times 1 over 3. The 3's cancel, leaving me with just pi over 5. Okay, does that jog a bell there? Okay. So now, okay, so you already told me period was going to be 2 pi over b, so it's going to be 2 pi over 3. That's unchanged, but look at how the phase shift changed. What's the phase shift now? To the left, pi over 5, not 3 pi over 5. Okay, so if we don't get it in that standard form, the phase shift is going to be incorrect. If the phase shift is incorrect, your graph is incorrect. Okay, so that's kind of a, that's not kind of a big deal. It is a big deal. All right, so let's go to our graph. And again, I want you to only deal with amplitude and period. Don't worry about phase shift yet. That comes later. So let's hit the 5 magics just by looking at amplitude and period. Where's the ending for this guy? Yeah, it's the same as my period, which is 2 pi over 3. So here's my ending, 2 pi over 3. By the way, you notice I'm going to the left, so that's why I'm not concerned about whether or not I have enough room. Okay, since I'm going to the left, I can just extend my x-axis. All right, take half. What's half of 2 pi over 3? Pi over 3. Half of is the same thing as doing 1/2 times. What's half of pi over 3? Pi over 6. Now let's count. You've got 1/6. Does this make sense if it's 2/6? Yeah, so what's the third one going to be? 3/6. What will I write down? Pi over 2. And then what comes after 3/6? Does this make sense for 4/6? Yes, it does. Okay, so take half, and count. All right, I told you we were gonna run into numbers that were different. Our amplitude is 1. So let's go ahead and put that in there. And again, we want to get our 5 magics from the start. Don't worry about the shifts yet. Okay. So, tell you what, why don't you draw in the 5 magics? Use X's. Draw in the 5 magics pre-shift. Where do my magics begin? Maximum. And then from there? Yep. And then minimum. And then? Yeah. And then maximum. Okay. So 5 magics. Now we want to take our 5 magics and we want to shift them to the left, pi over 5. And we say, okay, goody, how many blocks is pi over 5? I have no idea. Because pi over 5, we've never worked with pi over 5 before. So what do you do when it's so ugly that it's not on your graph? Like the last one, I could look and see 3 pi over 2, oh, that's 6 blocks, no problem. Let me ask you this. Where, if I were to draw pi over 5, where would it land? Yeah, Dylan, why do you feel like it's going to land between pi over 6 and pi over 3?
Pi over 5 is larger than pi over 6, and it's smaller.
Yeah, basically because 5 is between 6 and 3. Right? So pi over 5 has to be between pi over 6 and pi over 3. Which one do you think it's closer to, the pi over 6 or the pi over 3? The pi over 6. Okay, so we know that. So for now, since we're kind of guesstimating here, and I'm going to use a different color, since we're kind of guesstimating, let's put pi over 5 right here. How many blocks is that? Now, be careful. How many blocks to get to pi over 5? I got 5 blocks. 5 blocks to get to pi over 5. And which direction are we shifting our magics? To the left. So let's take all 5 of our magics. Let's shift them to the left. How many blocks? 5 blocks. We'll get the magic values here in a minute. Okay, but for now, let's just get the coordinates. So let's take our maximum and go backwards 5 blocks. So 1, 2, 3, 4, 5. So that's going to leave me right here. Maximum, backwards, maximum to the left, 5 blocks. Okay? Now, take your x-intercept, the pi over 6, backwards, to the left, 5 blocks. Now, I need to extend my x-axis because that wasn't long enough. All right, minimum. Take your minimum, shift it to the left 5 blocks. Then you had your x-axis, backwards 5 blocks. Lastly, your maximum, backwards 5 blocks. And you can go ahead and draw your curve. How many of my 5 magics do I have? None. You have none. Well, let's do a little bit of math. You got your calculators, right? Let's do a little bit of math. Okay. So I'm going to come down here to the bottom, and I'm going to make myself a chart. All right. What were my original 5 magics? What were my original 5 magics? So the first one was at 0. Where was the second one? Pi over 6. All right, somebody else. Where was my next one? pi over 3. And then where was the fourth one? Pi over 2. Where was the last one? 2 pi over 3. There was my original 5 magics, right? And then we took our original 5 magics and we shifted them to the left. Yeah, it was 5 blocks, but how much was 5 blocks worth? Pi over 5. So we took each of our 5 magics and we subtracted pi over 5. Okay, so what is, you don't need a calculator for this first one. What's 0 minus pi over 5? Negative pi over 5. So we can go ahead and put that one on our graph, negative pi over 5. That one's easy. Okay, so we're just doing some math here. The next one that we're going to do is pi over 6 minus pi over 5. Now, I told you to get out your calculators. You can do this either in your head, or you can do this with the aid of a calculator. Just don't use the pi buttons. Think of it as a 1/6 minus a 1/5. Okay, because I don't want decimals from you. I want fractions. Okay, so 1/6 minus 1/5. Say it again. Is it? I didn't get 1 over 30. Okay, I didn't get pi over 30. I got negative 1/30, right? Because it's a 1/6 minus a 1/5, and so it's a smaller number minus a larger number. Okay, so negative pi over 30. All right, we can put that in. So negative pi over 30. So for the next one, you're going to want to type in 1/3 minus 1/5. And what do you get? Yep, 2 pi over 15. That one's where my minimum value is. Okay, and then the fourth one, you want to do 1/2 minus 1/5. 3 pi over 10. So this is at my x-intercept here. And then lastly, you want to do 2 pi over 3 minus, or sorry, 2/3 minus 1/5. 7 pi over 15. And this is going to be my maximum here. So then, and I could have done this, guys, on the last one, but it was just so much easier to count blocks. Okay, so when it's already one of my blocks, I can just count the existing blocks and shift that many. But when it's something that's not there, first of all, I have to guesstimate where to put it. And then secondly, I have to find out, well, what are those actual values? And I have to use some adding and subtracting of fractions to do that. Okay, apparently okay, this is from my lab. I think what I was trying to show here is that how much I don't like some of the questions in my lab, which is why I'm forcing you to do some stuff on paper. This is probably not in your notes. Am I correct in saying so, Leo? Is this in your notes? Yeah. I think this was just something that I put in my own notes to show you. So here's one of the things that I don't like about my lab. I don't like the concept of give me the amplitude, period, and phase shift, and it's multiple choice. That bugs me. I want you to be able to do that on your own, not just pick, 25% chance of getting right, eeny, meeny, miny, mo. All right? So yes, you'll have that on my lab, but when it comes to the paper portion of the test, I won't have stuff like that. Okay? You'll have to find it yourself because you know what those formulas are. And the second thing that I don't like is the whole concept of multiple choice graphs. that just, Pearson and I have gone arounds and arounds and arounds and arounds and arounds about this, even as recently as Thursday, okay? So I cannot stand multiple choice graphs, but they're there. So you'll have some in the digital portion of your homework, but you also need to come up with graphs on your own without just eeny, meeny, miny, mo, okay? And the second thing I hate, okay, you ready for this? Here it says that the phase shift is negative pi. I will not accept that as an answer. Are you hearing me? Okay, now there are a lot of things where I'm like, I hate it, but my math lab does it, so I'll accept it when the student does that. This is not one of those occasions. Okay, now let's take a look. What would I require you to tell me the phase shift is? To the left, pi. This whole negative pi nonsense doesn't tell me anything, because negative can do several things. Negative can tell me to go down. Negative can also tell me to go to the left. I want to know that you know what the direction is. Okay? So my lab might let it go, but Ms. Roberts is not going to let it go. Okay? I'm not going to do it. You have a song in your head now? Gotcha. Okay. Let's go and talk about the vertical translations. Vertical. So this is the last way that we're going to mess with our parents. Now, do you remember what I told you I like to do with the C value whenever I had it? I like to move it to the back. Okay. Now, if you look at my original equation here, what's the amplitude? Yeah, it's 3. But is there a possibility that if you're not really all in, if you're not really focused, that you might think the amplitude is 4? Because it's the first number up there. That's why I like to take that C value, the guy that's being added or subtracted, I like to take it and move it to the back, okay? At least mentally, I like to move it to the back, all right? If we have here y is equal to, so if I do move it to the back, what does it look like when I rewrite it? Yeah, -3. That's the important part. I really wanted to hear you say the negative. Okay, -3. Is it already in standard form? Do I need to do any factoring? It's good. So x minus pi, and then I have my +4 that's now moved out to the back. Again, I don't care if you write that, but you at least need to think that so that you don't accidentally use the C value for your amplitude. Okay, so now let's list anything that we possibly know about this guy. So tell me something that we know about him. Amplitude, 3. Okay. Somebody different. What else do I know? Period is, yeah, and how did you get that? Our B value is 1. Good. What else? Yeah? You sure? Why is it to the right? Yeah, it goes backwards from what we expect. So we're going to go to the right pi. What else do we know? Now, I usually either call this a VS for vertical shift or a VT for vertical translation. I don't care. Okay, so I've used both. So that's fine. What is my vertical shift? And again, you should be telling me distance as well as direction. Okay, 4 up. Is there anything else that I need to know? Is there anything else that I could list? What are we missing? Yeah, it's a reflection. Why is it a reflect over the x-axis? Yeah, it's a -3. The amplitude only deals with the numeric parts, but that negative part does affect the graph. So you do have to be explicit about what that is. Now, when I'm grading these on paper, okay, so I'm not talking to my lab here. When I'm grading these on paper, this is the first part of the grade. And so a lot of times what's gonna happen is, this might be the point system that I use. I'm not locking myself into this. I'm just telling you this might be what I do. I might say, hey, this guy, that's 1 point. Here's another point. Keep track, okay? How about? Here's 2 points, 1 for the direction, 1 for the distance. 2 points, 1 for the direction, 1 for the distance. 1 point. So how far am I so far? And I haven't even graphed anything yet. 7 points. And my graph might be worth 3 points. Okay, 3 or 4 points, maybe. So the deal is I expect you to have all this stuff. If this stuff isn't right, you can't get your graph right, right? So I'm going for this first. This is what I want to check on first, and then we'll go to the graph and make sure that your graph matches everything on that list, okay? All right, so let's go and graph this guy. Let's see, am I going to have room to shift? I mean, if I don't do anything extra, if I do everything the way that I've been doing things, am I gonna have room to shift? No, because I gotta shift to the right. Okay, so let's squeeze things in, simply because I won't have room to shift, okay? So then what's my ending value gonna be? 2 pi, so you remember that you only pay attention to amplitude and period for your 5 magics. Only pay attention to those guys for your 5 magics. Okay, so we're gonna go to 2 pi. I'm squeezing things in so that we'll have room to shift. Take half. Pi. Take half. Pi over 2, and then count. So you've got 1/2, 2 halves, 3 halves, and 4 halves. Let's get our amplitude on there. And let's get our 5 magics, the original magics, the pre-shift magics. So where is this guy going to begin? Is it gonna begin at a max or a min? At a min. Why a min? Don't forget you've got a reflection. Okay, so let's we'll start at the minimum. Where does it go from there? X-axis, and from there? Maximum, keep going. X-axis, and lastly, down to the minimum. Okay, so now let's talk about our phase shift, the horizontal movements. How far do I need to go? I need to go pi. How many blocks is that for me? I think it's 4. 4 blocks to the right. Okay, so I need to take everything 4 blocks to the right. Oh, but wait. Not only do I need to take everything 4 blocks to the right, I also have a vertical translation. And how am I translating vertically? Up 4. So let's take everything to the right 4 blocks and up 4 blocks. Okay? So this first guy then, I want to go to the right 4 blocks and I want to go up 4 blocks. So I'm going to put a new coordinate, right 4, up 4. That's my minimum. That's my new minimum. Okay, then take your x-axis, shift it to the right 4 and up 4. That's going to be a new x-intercept, even though it won't be an x-intercept anymore. Okay, now you're on your maximum. Take your maximum to the right 4 and up 4. That's going to take you up into the sticky note. right 4 and up 4. That's going to be your new maximum. Back to the x-axis, to the right 4 and up 4. And lastly, your minimum, to the right 4 and up 4. Do I have magics for everybody? Is everybody labeled? No, but the nice thing about this is that I can just keep on counting. Okay, so let's go back and count. We had 1 half, 2 halves, 3 halves, 4 halves. Where's my next one? 5 halves. And then my last one? Yeah, 6 halves, which reduces to 3 pi. Sometimes my lab will ask you what is the range. What's the range? What's the domain? They won't ever ask you what the domain is. What's the domain? Negative infinity to positive infinity. Remember, this is a wave that keeps on going and going and going in both directions, right? So they'll never ask you what the domain is, but they might ask you what the range is. What's the range of this guy? From the minimum to the maximum, what is that? 1 to 7. 1 to 7. The bottom of the graph occurs at 1, and the top of the graph up there at the maximum, okay, that's why it's called the maximum, occurs at 7, because we were at 3 and we went up 4 from there, okay? All right, I have 6 minutes. I don't know if I'll be able to finish everything, but I can at least get a good start on this one. Okay? So, amplitude. 1. Amplitude is 1. Period. Tell me how to find it. Yeah, so this is going to be 2 pi over 2, which is pi. Phase shift. To the left. How far? Pi over 4. Vertical shift. 1 half. Which direction? Up. Anything else? Any reflections? No, there's not. Okay. Will I have enough room to shift, or do I need to finagle what's already there? I have enough room. I have to go to the left. I've got plenty of space. I might have to extend my x-axis, but I've got space. Okay. So where's the ending? Pi, middle, quarter, missing value. 3 pi over 4. Remember, you're counting. So it's 1 4, 2 fours, 3 fours, 4 fours. Amplitude is 1. Okay, hang on a second. I am going to do this. So be thinking ahead. Your amplitude is 1, but what does my vertical shift look like? A half. So here's what I would do. I would either make my unit 1 like 2 blocks or 4 blocks, because then it's really easy to shift a half, right? I was about to make it 3 blocks, and that's going to be a pain in the bahonkus, right? So either make 1, 2 blocks, or 4 blocks. Let's just spread it out here. So let's make it 4 blocks. I might be sorry, but not 4. That's my 1. My 1 is 4 blocks. So that means when I shift a half, how many shifts are that? How many blocks am I shifting? 2 blocks, because that's a half. All right, let's get our magics in there. Pre-shift magics. So where do my pre-shift magics begin? Origin, right? X-intercept. From there it goes where? Yep, max, X-intercept, min, X-intercept. Okay, which direction? Well, we know we're going to the left. How many blocks left will we go? 4 blocks to the left. Pi over 4 is 4 blocks. How many blocks up will we go? Yeah, so I want to shift everything left 4 blocks and up 2 blocks. Okay, I'm not talking in units, I'm talking in blocks. All right, so take this guy, it's at the x-intercept. Let's go left 4 blocks and up 2 blocks. And I need to extend my x-axis. Do the same thing for your maximum. Left 4 blocks, up 2 blocks. X-axis, left 4 blocks, up 2 blocks. Minimum, left 4, up 2. And then x-axis, left 4, up 2. You can draw your curve. How many magic values are you missing? Just one. And it's an easy one, right? What is it? Negative pi over 4. If you had been asked for the range on this one, what would the range have been? Negative 1/2 to 1.5 or 3/2 is the same thing. 1.5 is the same thing. Okay. All right. Any questions? It's 12:20. Any questions? Hey guys, have a good fall break. Enjoy. I will. Very excited.